Use key point to graph, state the domain and range, and tell me about the amplitude and period. Now, is the period for tangent the same as cosine and sine? Period for tangent is the same as cosine and sine. Okay, so can you please, Daniela, look at your notes? What's the formula for the period, in this particular case, is the period for tangent?
Pi over absolute value.
Great. Pi over absolute value of b, okay? So it's no longer 2 pi, it's just pi now for tangent. And it's also the same thing for cotangent. Mahina, what's b value for example 1a? 1. So that's just going to be pi, okay? That is just going to be pi. Now, let's talk about the amplitude. For tangent, can we see how high tangent goes? No, right? Because doesn't it go up forever? So there's no what? Amplitude. So if I put that on a test, that would totally be a trick question. You just write none. Okay. Then it says, hey, go and use your key points. I'm going to make the parent function over here. This is x, this is y equals just tangent of x. This is your parent. Based on your notes, okay, what are the 5 key points? Okay, let's start with the first one. Nicole, what's the first key point in tangent? 0, 0. Do you guys agree? Okay. Next key point. This one goes to Kelly.
Pi over 4, 1.
Very good. Okay. Alex, what's the next key point? Alex G, I'm sorry. Ooh, I forgot.
Pi over 2.
Very good. Okay. Jennifer, next key point, please.
3 pi over 4 negative 1.
Very good. And Emily T, last key point, please. Pi 0. Very good. So that's your parent. Yes, you should know those 5 key points really well, really fast, just like the sine and cosine. Now, I have a couple of transformations. Let's talk about this first one right here. -1 at the very, very end, and then there's another one right here, the 2 at the very beginning. Okay, so let's talk about, I guess we can start with the 2. Devin D, what's the 2 doing? What kind of transformation is that? 2 in the very, very front. What kind of transformation? Consult with your team if you must. It's still a vertical stretch because it's still in the very front, y'all. Okay, vertical stretch factor of 2 units. Okay, then Grant, the -1 at the very, very end. What kind of transformation is that?
Transformation right 1 unit.
Close, not right. Is there a quantity with the x? Okay. Okay, remember, it's only left or right if it has what? Parentheses, right? Because then we're grouping it with the x. It's not, we're moving it down by 1 unit. Down by 1. Okay. So here's my new table. Down by 1, is that changing y or x? Y. Okay, so x is going to stay exactly the same. And then the vertical stretch factor 2, changing y again. So we have 2 times y minus 1. Okay, 2 times y minus 1. So here we go. Let's use the transformation to fill out a chart. Jacob, can you give me the first point, please?
0, comma.
0, comma, not 0 anymore, 0, comma,
-1.
yes, you are correct, okay? Pi over 4, since we're not changing x, I'm just going to write pi over 4. Alex M, what's your new y coordinate for pi over 4?
1.
1. And then pi over 2. Is that going to change my asymptote? No, I'm not going left or right, so that's going to stay still as an undefined, okay? Then we are going to go to 3 pi over 4. Allison, what's your new y coordinate for 3 pi over 4? -3. And we're going to go to Logan. Last y coordinate, please.
Pi and -1.
Pi and -1, okay? All right, similarly, we're just going to plot your period is a pi. Do you guys want to do 2 to the right, 1 right, 1 left? What's your choice? 2 right, sounds good. Okay, here we go. If your period is a pi, 2 to the right goes all the way out to what? 2 pi. Okay. And just for kind of demonstration, I'm also going to do 1 on the left because I know some of you like 1 left, 1 right. This will cover all students, okay? One take mark is worth how much for this equation? A pi over 4. You're right. Okay, bless you. All right, here we go. I'm just going to make 1, 2, 3 up, 1, 2, 3 down. Okay. At 0, I'm going to plot a dot at where? -1. So go down to -1. Remember, we translated down 1 unit, so the center is no longer at the x-axis. Pi over 4, I'm going to go up 1. Pi over 2, what am I doing at pi over 2? An asymptote, you're right. Okay. And 3 pi over 4, -3. A pi, -1. So let's continue the pattern. I need to cover all of those tick marks on the right. Next tick mark over. What do you guys want me to do? Up, down, where are we going? 1, you're right, it's 1. Next tick mark, asymptote. Next tick mark, -3. Last tick mark on the right, -1, okay? So what's happening is, this is your tangent graph right here in the middle. Yes, it looks like a cubic, okay? So keep that in mind. I only have 2 dots on this side, so I'm gonna stop right there. I'm just gonna continue on the left-hand side. So the very first tick mark at -pi over 4, Christine, where do you want me to plot the very left-hand side tick mark? And then -pi over 4. Do you want me to go up, down? Where are we going with that? -3s, right? Very good. Okay. And -pi over 2, Parker, where would you like for me, what do you want me to do with -pi over 2? It is another asymptote. You're right. Okay. So connect those 3 dots to make another period. Then at -3 pi over 4, Kyle, bless you. -3 pi over 4, Kyle, where would you like for me to plot that dot? +1, -1, or -3?
Positive.
Very good. +1. And last one, at -pi, Carissa, where would you like that dot to be at? Very good. All right, so again, since I only have these 2 dots, I'm just gonna continue just like that. Okay. Then it's gonna want you to state the domain and range. Here we go, domain. Is it still all real numbers like sine and cosine? No, no longer. So, what are we doing? The domain. How do we state the domain? Where's your first asymptote at? Devin, see? First asymptote. What do you see? First asymptote. You can talk to your team if you must. First asymptote. Where is it at? Pi over 2. Okay, here's first asymptote. Next asymptote. Alyssa, where's the next asymptote at? What is it? Not 3 pi over 2, because look, Alyssa, 3 pi, oh, I lie. It is, I was going to say not 3 pi over 4, but you're right, 3 pi over 2. Woof. Sorry, Alyssa. It's totally right. What's a gap between pi over 2 and 3 pi over 2? What's the spacing? How much is that? What's that distance? What is it? A pi. You're right. That distance, y'all, it's a pi. And this is a -pi over 2, right? So what's this distance here? That's also a distance of pi. So remember, the domain is what we're excluding. We're going to exclude all of the asymptotes. So where are they located at? Where are all of them located at? How would we write that? Domain, all real numbers, excluding what? What are we excluding? What are we excluding? Pi over 2, very good, plus pi k, excellent. Where k is? What's k? Any integers, right? Any integer, perfect. Or could I say pi k, pi over 2k, where k is what? Any what? What kind of integer is k if I don't feel like writing plus pi k? If I just want to write pi over 2k, where k is, what are these? Pi over 2, 3 pi over 2. If I have to take a wild guess, the next one would be 5 pi over 2. So if I don't feel like adding pi k, where k is any integer, and I just want to write pi over 2k, where k is any what?
Odd integer.
Yes, that is another choice. Any odd integer. You're right. Okay, that's another choice. You don't always have to go the same way. All right, let's talk about the range. What is the range for this one, Vincent? You are right, it is. Okay, so let's see if we cover all of the answers. We used 5 key points. We stated the domain, we stated the range, we found the amplitude and the period. Okay, so keep in mind that the amplitude for tangent and cotangent will always be what? None. So that's a trick question, y'all. Okay, so if you see that, make sure we write none. Okay, then let's go and do secant. Okay, we're going to pick up the pace a little bit once we have covered all of these. Where, again, we will start with the parent. Oops, I meant to make a chart here. We'll make the parent on this side. X and y equals secant of x. Okay, let's go and find the period. Okay, go back to your notes if you have to, or consult with your team. Gabriella, what's just the formula for the period of secant? Close for secant. You guys agree? Okay, remember secant, it's a reciprocal of what? Cosine, so it has to be quite similar, okay? So what's the value of b, Connor, in this problem? 2 pi divided by absolute value of what, Connor? No, what's your b value? Pi over 2, very good. So when we are dividing, we are going to multiply by its reciprocal. So Connor said, yes, the pi will cancel. That's how I came up with 4. Now let's talk about the amplitude. Okay, Sinjin, what's the amplitude for secant? Close. Look back in your notes on secant, dear. What's the amplitude on secant? Consult with your team if you have to. None. Guys, how come secant does not have an amplitude? How come secant does not have an amplitude? Natalie, how come secant does not have an amplitude? Yeah, the graphs go up forever and it goes down forever. Perfect. Okay. Okay, here we go. Let's start with the first point in the parent function. Ethan, it's out for the week. So, Gracie, what's the first point in the parent function? 0, 1. True or false? Okay. Emma S is not here, so we are going to go with Natalie. Next order pair for the parent. Pi over 2, comma 0. Do you guys agree for secant? Cautiously. Do we agree for secant? At pi over 2, cosine is 0. But secant, what happened when you take the reciprocal of 0? It is now asymptote, undefined, bless you. Okay. Dahlia, at pi, what is secant at pi? Is it true? Look at your parent function again. At pi. Think about cosine at pi. -1, very good. 3 pi over 2, Jacob, 3 pi over 2. What is the y value, if any?
Undefined.
Undefined. And Alex G, 2 pi. 1. Perfect. Okay. I will now put all the transformation over here. Okay, we have a negative in the front, a -3. What should we do with that -3 in the front? In the very, very front. Changing y or changing x? Changing y. So I'm going to add, subtract, multiply, divide. What are we doing? What are we doing? Natalie? Yep. Take y, multiply by -3. There you go. Then, oh my, the pi over 2 inside with the x. What do you want to do with that one, Daniela?
Sorry.
The pi over 2? Changing y or changing x? Good. What do you want to do with x?
You want to multiply 2 over pi.
Yes, very good. Multiply by 2 over pi and times x that way. Perfect. Okay, here we go. Alyssa, first ordered pair with the transformation, please. What is it now? Very good. Okay. Grant, next order pair with the transformation. Yes, very good. Sophie, third order pair with the transformations, please. 2, 3. Do you guys agree so far? Look at the first 2 or the first 3 points on the x-axis. What's the spacing? What's the gap? What's the difference from one x value to the next? What's the increment? 1. So I have 2 more to find. You don't have to do any more multiplication. Can I just go and count? Guess what the next 2 x inputs are? Just simply 3 and 4. That's it. Okay. Now we just have to find the y value. At 3, Parker, what's the output? You are right. At 4, Allison, what's the output? Yes, that's it. Okay. I'm going to graph, the period is 4, so what I'm going to do is I'm going to do 4 here. That means I'm going to go 8 here. I will also cover my students that like the negative side as well. So I don't have to label my tick marks, y'all, because each tick mark is just worth how much? 1. That's right. This is a nice one. Okay. All right. At 0, I'm going to go all the way down to -3. Here we go. And then at 1, what am I doing at 1? What am I doing at 1? Making an asymptote. Very good. Okay. Then at 2, I'm going to go all the way up to 3. Then at 3, I have another asymptote. Okay. Then I'm just going to keep on going. Here we go. Repeating. At 4, what would you like me to do, Mahina? Yes. Very good. At 5, Emily T, what would you like me to do at 5? Very good. At 6, Vincent, what would you like me to do at 6? Very good. At 7, Jennifer, what would you like me to do at 7? Close. Vincent already told me at 3 at 6. Very good. Okay. Then I'm just going to go to the left side. At -1, Alex M, what would you like me to do at -1? Very good. At -2, Nicole, what would you like me to do? Very good. At -3, Kelly, what do you want me to do? Right. Can you guys see that I have a lot more than just 2 cycles here? Okay. I just have dots. Now what? Okay. Kyle, I have dots. What do you want me to do with those dots?
Wait, no. Okay, so what do you do? You do a parabola?
Yes. Okay. Do a parabola. Make sure it opens in the right direction. Okay. So these are them. Okay, so those are them. I definitely have more than 2 full cycles. Now we have to state the domain and the range. Domain. Okay. Remember, domain is what you're going to exclude. You're going to exclude all of the what? The asymptotes, okay? Where, Carissa, are all the asymptotes at? You're right. So I'm just going to write exclude all odd And I think you meant integers, right?
Yeah.
Okay. Exclude all odd integers. Yeah, just spell it out. Okay. Or if you want to go fancy, can you write 1 plus? 1 plus what? What's the gap between one asymptote to the other? How many spaces is that? 2. So 1 plus 2k, where k is any integer. That's another way too. Okay. Here. Or 1 plus 2k, where k is any integer. I would also take that. Okay. Range. Devin D. Range. What's the range? Inclusive, right? And then union that with inclusive. Very good. 3 to infinity. Remember, in the interval notation, make sure you write small numbers first. Okay. Perfect. Remember, the transformation are still the same from sine and cosine. That's why we spent so much time graphing sine and cosine. Okay. Because the transformation are just used again over here. All right, let's move on to this one. Let's do parent function first. X and y equals cosecant of x. Okay. Order pair, first order pair for just the parent. Logan.
0, 0.
0, 0. Is Logan right? For cosecant? Remember, sine at 0 is 0, but cosecant at 0 would have to be undefined. Okay. Christine, next order pair, please. Pi over 2, 1. Very good. Devin C, next order pair, please. Pi undefined. Beautiful work. Okay. Next order pair, Emily T. 3 pi over 2, negative 1. And last order pair, Devin C.
2 pi.
Okay. Your card just got put back in the pile. Okay. Let's find the period. What's the formula? Okay, just the formula only, please, Nicole.
2 pi.
O pi over b. Very good. Okay, what's our b value for this question, Kelly?
1.
Very good. So, guys, just 2 pi. There we go. Amplitude. Sophie, what's the amplitude for this question? Very good. Okay, guys, tangent, cotangent, cosecant, secant will not have any. Parker. Okay, transformation. The 2 in the front, Parker, I'm going to write my new transformation table over here. The 2 in the front, Parker, is that going to change my y or change my x? What are we going to do to change y? Very good. Multiply by 2. The minus 1 at the very, very end. Alex G, changing y, changing x. Very good. Add, subtract, multiply. Very good. Okay, that means, as you can see, there is nothing changing x, okay? So, Daniela, first order pair, please.
0,
Perfect. This is because, remember, there's no left or right, so that's why your asymptotes are still staying the same. Alyssa, next order pair, please. Pi over 2, 0. Is that okay? No? Remember, 1 times 2 minus 1. 1. Is that better? Okay. Very good. Alex M. Third order pair, please.
Pi.
Pi undefined. Sinjin. The next order pair, please.
3 pi over 2, negative 2.
3 pi over 2, negative 1. Or negative 3, you said? Okay. Sorry, I'm really old. Can't hear very well. Okay. 2 pi. Last order pair. Okay, Gracie? Undefined. Okay, all right. Let's plot the dots. Your period is 2 pi, so that means I'm going to go 2 pi here, and that means 4 pi. For those of you who like to go 2 cycles to the right, I will also cover my other group of students that like 2 pi's. Oh, 1 period on the left. Okay. All right, looks like I'm going to go up just 3 units and down 3 units. Okay. At 0, what are we doing at 0? What do you want to graph? How do you want to graph 0? Mahina? Yes, I will. And if you don't think I can see that you can put an asymptote on the y-axis, you can just do a couple dashes at the top of it or the bottom of it, just like that. Okay. Then at pi over 2, I'm going to mark a dot at 1, just like that. Okay. Then at pi, I'm also going to make another asymptote right there. At 3 pi over 2, negative 3. At 2 pi, another asymptote, and repeat, okay? Next tick mark. Where would you like me to plot the dot, or what do you want me to do, Grant?
I'm sorry.
Yeah, the first one to the right of 2 pi.
Oh,
At 1, good. Next tick mark, Natalie, what do you want me to do?
Asymptote.
Very good. Next tick mark, Dahlia. On the positive side. We're going to fill up all the positive side first. Negative 3. And 4 pi, Jacob. What do you want me to do with 4 pi?
Asymptote.
Very good. Okay. All right. At negative pi over 2, Gabriella, what do you want me to do? Negative 3? Do you guys agree, Gabriella? Okay. At negative pi, Connor, what do you want me to do? Asymptote. Negative 3 pi over 2, Devin D, what do you want me to do? 1. And negative 2 pi, Logan, what do you want me to do? Excellent. All right, guys. Okay, I have a bunch of dots. Christine, what would you like me to do with those dots? You're right. Let's make the parabolas out of these guys. All right. And if you already finished the parabolas, you can start thinking about your domain and range. So here are all my beautiful parabolas. Okay. Domain and range. Okay. So Allison and Allison's team, start thinking about what you want to write down for the domain. So consult with your team if you must. Pi k. Pi. Oops. Gracie, can you go hit my keyboard for me? Okay. So Allison said it's going to be pi k, where k is any integer. Do you guys agree with Allison? Yeah? Okay. Because if you see this right here, the first asymptote, it's going to be at 1, then 2, then 0. Those are all integers, aren't they? So you don't have to do anything special. They're just all integers. Very good. Okay. The range, Vincent and Vincent's team, consult with your team if you must. What's the range for this particular equation or graph?
It would be negative 50 to negative 3 inclusive.
Very good.
With inclusive 1 to 3.
Beautiful. Nice job, Vincent. I'll move that up just in case. Last problem of 6.5, and then I will take homework and stamp your homework, okay? Take homework questions, that is. Of course, we will start with the parent function. Why don't you and your team make just the table for the parent function? Okay, x, y equals cotangent of x. Bless you. So I'll wait for a couple minutes for you to make the parent table for cotangent. Once you have the table for the parent, don't forget to consult with your team. Make sure your table is right. If the table for the parent is wrong, then the transformation is going to be wrong. And I'm just going to call one of us to get us all 5 points. So please do consult with your team. You should already have the points, right? Okay. Remember, all of the parent are done. We're just using it now with applications or with transformations. If you know how, go and find the period. Go find the amplitude. Okay, all 5, okay? Here we go. Kyle, give me all 5 points for cotangent, please.
0, 0.
0, 0.
Pi over 1. Pi over 2, 0. Pi over 4, negative 1. And pi.
Okay. I wrote what Kyle told me to write. Are those 5 points correct? Something's a little bit off. Tell me what. Yes, 0 is also undefined. Remember, cotangent and tangent, I should have how many asymptotes for the period? I should have 2, right? So, and cotangent is what divided by what, by the way? What function divided by what function? Cotangent is what divided by what? What is it? 1 divided by tangent is correct. What else if I were to use sine and cosine? Cosine divided by sine. Remember, it's undefined when sine is what? 0, because sine's in the bottom, right? Again, it's undefined if sine is 0. So what location will give you 0 for sine? At either 0 or pi, okay? So those 2 locations has to be undefined for cotangent. Okay, you have a lot more transformation this time around, so let's make, oh, by the way, period. What's the formula, Carissa, and only formula? Pi over b, very good, okay? The b for this one is what? What is the b for this one, Sinjin? Close. B is, remember, absolute value. So eventually it will turn out to be 1/2, but yeah, so that's going to be. So I'm going to multiply by its reciprocal, so that's going to be 2, so that's going to be 2 pi. Yes, no, maybe? Okay. Amplitude, what should your answer be, Natalie? You are right. Beautiful. Okay. So I will now make a transformation chart over here. The 2 in the very, very front. Dahlia, what do you want to do with the 2 in the very, very front? The 2 in the front, what do you want to do? Why negative 2? Just 2. To which one? It's totally right. The 2 in the front is a, what kind of transformation is that? It's a vertical stretch. So we are going to multiply it to which one? The y. The y. Good. The negative 1/2, what are we going to do with what? Changing which one? X. What are we going to do? Now I can multiply by negative 2x, just like that. Remember, with the horizontal, by now we know that we kind of have to go a weird order, okay? And then the -2 at the very, very end. What the heck is that one? X or Y change? Y. Add or subtract? Subtract. So here we go. That's a lot of 2's, okay? All right, new point. Here we go. It used to be at 0, undefined. Jacob, give me that very first one. It's still 0, undefined. Very good. Okay. Next order pair, Connor, what is it? Negative pi over 2 comma 1. Is Connor right so far? I don't know. Connor told me 1. Should be 0? Is that better? Oops. Okay, is that better? Okay. Third order pair, Devin D. Negative pi, I'm sorry, one more time. Negative pi. -2. Is that okay? Next order pair, Vincent?
Negative 8 pi over 2 and negative 4.
Negative 4. Is Vincent okay? And next one, Jennifer.
Oh, it's negative 2 pi on that one.
Negative 2 pi and new 5. Perfect. As you can see, I'm just going to do a negative 2 pi over here because I have a lot of negative inputs. And I'm also going to go all the way to 4 pi to the right. I'm going to start with the asymptotes because to me that's the easiest. The asymptotes are both at negative 2 pi and where else? 0. And again, if you don't think I can see your pencil mark on the y-axis, just go above it. No worries. Okay. Then at negative pi over 2, I'm going to be at 0. Oh, I need a couple of tick marks on the y. I need negative 4 of them. 1, 2, 3, 4. There you go. So at negative pi over 2, I'm going to be at 0. At negative pi, I'm going to go down at negative 2. Negative 3 pi over 2 is going to be negative 4. So here's one full cycle on the left-hand side of my y-axis. And I'm just going to repeat that, okay? At pi over 2, Gabriella, where do you want me to plot pi over 2? Is that okay? Yeah, okay, at negative pi, so that's going to be at negative 4 for pi over 2. Okay? It's going to repeat from left to right, okay? At pi, Kyle, what do you want to do? Where do you want me to plot pi?
Negative 2.
Negative 2. At 3 pi over 2, Daniela, what do you want me to plot?
0.
Good. At 2 pi, what do you want me to do, Alyssa? 2 pi. You're right, I will. Okay. All right, connect those dots. Next one, okay. Logan, what do you want me to do at the next tick mark?
5 pi over 2 negative 4.
Very good. Okay. At 3 pi, Gracie, what do you want me to do at 3 pi? Very good. At 7 pi over 2, Mahina, what do you want me to do? Last one at 4 pi, Carissa, what do you want me to do? Okay, here we go. There you go. 3 beautiful full cycles. Let's do domain and range, and then I will take your homework questions. All right, Christine and Christine's team, think about the domain. Get ready to tell me what you want me to write. And we'll go the range. Allison, tell me the range. You're right. Okay. The domain's a hard one. So, Christine, whenever you and your team are ready, let me know. What would you want to write down for the domain? Okay, so Christine said, is that what you want to exclude, right? Okay. Christine said, I want to exclude pi k, where k is any even integer. Is there another way of writing that? Or, that's true. What's another way of writing that? You're right. It's 2 pi k, where k is any integer, right? Even number, it's always 2 something. Okay, so that's exactly right. Perfect. That is the end of, look at that. That's all of 6-5, y'all. Take out your homework.